Hi, my name is Ron Dorn, and I'd like to walk you through the example of how to do the rates of change number 2 in the Grand Canyon to figure out the rate of incision, the rate of widening of the Grand Canyon, and the rate of plateau lowering. So I'm going to share my screen, and I'm in Canvas in the instructions, and I'm also got the Grand Canyon geomorphology game ready to go. So I'm instructed to fast travel to, I'm going to get rid of the map key and the map so you can see better what's going on. And I'm going to fast travel to, the instructions are 36.0530 and minus 111.7710. And I'm at a little hill on the plateau near the Grand Canyon. This is one of a few different places that's pretty unique in that there's a lava flow on top of the location, and the lava flow protects sediments underneath it. The lava is much more resistant to erosion. The lava flow is 9 million years old. These are instructions provided inside Canvas, and I'm walking you through it. So I'm looking now at the top of the lava flow at an elevation of 2131 meters here. So I'm going to run my avatar off the top of the plateau to the surrounding landscape, and it's 1951 meters. So I write down the elevation 2131, and the base of the hill is 1951. I'm provided in the instructions that the age of this lava flow is 9 million years. I subtract the 2, it's 180 meters. Divided by 9 million years is 20 meters per million years. So now I have the rate of lowering. Now the question is, what's the rate of incision? So I'm instructed to go to 2 locations on either side of the Grand Canyon. And the instructions are near the junction of the Little Colorado River and the Grand Canyon, but I'll just go there and fast travel. One side is 36.2069, and the other side is minus 111.9321. I fast travel there, and I'm sitting up on one side of the Grand Canyon, up on the rim. The elevation is 2611, and then these are X and Y coordinates that we're going to use to calculate the distance to the other side of the Grand Canyon. The game has meters from the southwest corner in the X and the Y direction. And to calculate distances, you just have to use the Pythagorean theorem, and I'll walk you through this very simple process. And it sounds like it's middle school math tear, but it's actually way simpler than you remember from middle school, when perhaps you were frightened, or perhaps hopefully it wasn't difficult for you. So now I'm going to turn off the game, because the data you're going to get are something that is not going to be identical. Everybody's going to be given a different problem. And so I'll just walk you through the data extracted. So inside the Canvas instructions in this example, one side of the canyon is this information. Another side of the canyon is this information. And the third piece of the canyon is the depth, that information. So the problem of calculating the rate of incision is this equation right here. So let me blow it up so you can see it. You've got the elevation on one side of the rim and the other. You're just going to take an average of the two rim sides. So you add them up and divide by 2. And I'm sorry, you add them up and divide by 2, and that's an average elevation for the rim. Then you have a depth of the Grand Canyon. So you take the rim divided by the river elevation at 901 meters, and the depth is 1350 meters. So you take the depth and you divide it by the given 3.6 million years for the canyon to its size, and that's a rate of 385 meters per million years. So you've got 20 meters per million years for the plateau lowering, 385 for canyon deepening. That explains why that there's a canyon, because the river's cutting much, much faster, more than 10 times faster than it is the plateau is eroding. So now we have to figure out the rate of widening. And for this, you need the X and Y coordinates that you've got from the 2 different rims. And just for the sake of making intuitive understanding, I've gone ahead and plotted the X and Y coordinates as these blue dots. One XY coordinate, the other XY coordinate. So you're going to need to subtract or to get the difference between these 2 distances. 33,468 and 31,477. Doesn't matter the order it is, put the bigger number on top, pick the smaller number on the bottom, subtract them, and that's the Y. Put the bigger X on top, put the lower X on the bottom. That's the distance in X. So now you've got an X and a Y. You can use the Pythagorean theorem, or you can click on this link, which calculates you the hypotenuse, or you can do it by hand. So I've gone ahead and taken a screenshot of what this calculator looks like, and I've shifted it to meters, but you don't have to do that. So I've entered in, and it doesn't matter which X there is, or which is A or B. You can flip them, the result's going to be the same. One number, 1,991, 13,994. That's just, remember, that's the distance, the difference between the X and the Y. And it gives you the hypotenuse, which is the number of meters it is across the entire Grand Canyon. So then you take that distance across the Grand Canyon and you divide it by the length of time that the canyon has been in existence, 4.8 million years ago, and that's almost 3,000 meters per million years. So now you have calculated, with your example, a rate of downward erosion, a rate of river incision, and a rate of canyon widening. So this is what the question is going to look like. It's going to have these 4 parts, and then you're going to compare these rates to the conceptual model. And this is a random question pulled out, and you're going to have to figure out which one of these answers is the right one. But just take a look at the distances and the differences between them. In one of these potential answers, it has a plateau lowering, which is way higher than incision or widening. In another answer, plateau lowering is the smallest, river incision is super deep, and widening is between. In another answer, they're about the same. And in a third answer, they've jumped by orders of magnitude, pretty much like the example jumps by an order of magnitude. What I mean by an order of magnitude is a different digit. Plateau lowering in the order of 20 meters per million years for this example, river incision on the order of 300 to 400 meters per million years, and widening on the order of thousands of meters per million years. So each one of the wrong answers will be different for the question you're given, but don't panic. Just kind of look at it in terms of common sense. The wrong answers are going to be way, way off. What we're looking for is the idea of you actually testing the scientific model of the idea of interpreting this amazing landscape of the Grand Canyon using data. I hope you find this example of using science to test an idea, not to prove something, and also using real scientific data, because these geovisualizations have the real McCoy. You're not getting fake stuff. You're getting stuff downloaded from NASA and from the US Geological Survey, and that's what you're working with. So I hope you have fun, and I hope you're not finding it's too difficult, but interesting. But in the end, remember that only the correct answers count towards your grade. So taking a risk and trying something like this, give it a try, have fun, gain confidence.